Now, in the questions that we've already encountered, we either had or someone had found the margin of error based on the interval, or it was just given to us. But how can we calculate this margin of error from scratch? Because that's what we need it in. We need it in margin of error form to go plus and minus from that point estimate to create these intervals. We're going to start with the empirical rule. So as a reminder for the empirical rule, if you have your mean in the center, or if you have met the central limit theorem, so if you know already that you are dealing with a symmetric normal distribution, then you know the following are true. You know that 68% of the values fall within one standard error of the sample mean. So we can say we are 68% confident that the true value of the population mean is within one standard error of X bar. We are 95% confident that the true value of the population mean is within two standard errors of X bar. And we are 99.7% confident that the true value of the population mean is within three standard errors of X bar. So these are the first confidence levels that we concern ourselves with, are these ones that are from the empirical rule. The 95% confidence level is the most commonly used, although you can technically use any confidence level you want. But why is this one so desirable? Notice that if you go from 2 standard errors to 3 standard errors, you increase your confidence very little. You go from 95% confident to 99.7% confident. So you only gain a little bit of confidence, like 4.7% there. If you decrease from 2 standard errors down to 1, you lose a ton of confidence there. I mean, I went from being 95% confident in something to only being 68% confident. So what it basically is it's kind of the sweet spot. That 95% confidence level is where you can have a high level of confidence in what you're saying without getting so wide with your interval that it starts to not even be helpful or make sense. The question then is always asked, why would we not want to be 100% confident in our statements? That seems like it would be desirable. I want to say something with total full confidence in what I'm saying. And it's a great thought. But in order to be 100% confident in your statement, your interval would have to span from the very lowest to the very highest values possible. So that would be like me saying, for instance, that I am 100% confident that you will score between a 0 and a 100% on your next exam. That's true. It's a true statement, and I am totally confident in it, but it's basically not helpful at all. It gives no useful information. If I've spanned every grade possible, that tells the reader absolutely nothing about you as a student or what's going on with the next exam. If you could get somewhere between a 0 and a 100, tells me nothing, right? So that's why we can't write statements with 100% confidence. We instead back down a little bit. We're a little bit less confident, just barely, a little bit less confident. We back it down to 95% a lot of times. And then we're able to narrow that confidence interval in a bit so that it actually gives some relevant meaning. Okay? So let's look at something like this. It says a chain of pizza stores published data on the size of its pizzas in order to convince the public of their value. Using a random sample of 125 pizzas, the store found that the mean diameter was 11.5 inches with a sample standard deviation, or a standard error, of 0.25 inches. Create and interpret a 95% confidence interval for this situation. So we're given the mean, we're given the X bar value. We see that our sample size is plenty not large enough. The CLT is met, so we can continue on with this process. But instead of being given the margin of error, we're given the sample standard deviation. So we have sort of one more extra step to do on a problem like this. We know that our confidence interval can be built by going x bar minus the margin of error to x bar plus the margin of error, but we don't have margin of error. Margin of error and the standard error are different things. In order to create the margin of error, you want to look at your confidence level. In this case, we have a 95% confidence level. What that means is that we can get to that margin of error. The same thing as margin of error would be doing 2 of the standard errors. Let me write that in a better way. So 2 standard errors. 2 standard errors is the margin of error. So I could do x bar minus 2 standard errors for the low end, and then I could do x bar plus 2 standard errors for the upper limit. So it's just a slightly longer calculation, but not much. So our x bar in this case is 11.5, and we're going to subtract from that 2 times 0.25. And then for the upper limit, we're going to go 11.5 plus 2 times 0.25. So we've got 11.5 minus 0.5 for the lower end, and 11.5 plus 0.5 for the upper end. So this actually turns out to just be from 11 to 12 inches. That's my confidence interval. To interpret this, what I would say is I am 95% confident that, and that's how you always start your interpretations of a confidence interval. When you have the confidence level, you want to include that in your interpretation. So that's how confident I am. I am 95% confident that the mean diameter of all pizzas from this store, right? Because that's my population parameter, all the pizzas diameters. All the pizzas from this store. That mean diameter of all pizzas is between 11 inches and 12 inches. So sort of as a note here, the general interpretation structure for these is, you can write it as I am blank % confident that, and fill it in with whatever confidence level you're given. So if it's 95 or 99.7 or 68%, or later we will do other ones that aren't in the empirical rule. We might do 90s or 80s or things like that. So you fill in that blank. I am 90% confident that, and then you fill in the next blanks with whatever the population parameter in question is. So in our case, it was the mean diameter of all the pizzas. So you fill that in with whatever context you have. So I'm 95% confident that is between, and then you fill in your blank and blank with whatever your lower and upper limits are.